Long, long ago, in a land far, far away, a web machine designer thought cantilevering was a good idea. Little did he know how dangerous those woods were and how... Welcome to Web Handling. My name is Dave Roisum. In this video, we will spin some of my favorite fairy tales on cantilevered rollers. To cantilever is to support rollers from one end. This might be done with either single or double wall frames. Double wall frames are match drilled and have the advantages of being able to drive rollers and possibly align them much as we would expect of most wider machines. The commonly given reason for cantilevering machinery is that they are easier for the operator to access, such as for threading. In any case, application is strictly limited to narrow webs for reasons we will see shortly. The tale of the threading ease. Narrow web machines are already the easiest to thread because it is but a short reach to the center line of the machine. Also, threading is done while the machine is stopped or inching. However, consider the challenges met by the paper industry for decades. Their 400-inch wide paper machines with more than 100 rollers are threaded at speeds up to 6,000 feet a minute. Other industries that can thread at speed include glass and metals. So, the bottom line is this: stop your whining about threading ease! The tale of the cheap machine. You may have been told that the cantilevered machine is cheaper. Perhaps it can be made cheaper, but only if you compromise on standards for roller alignability and deflection. If you hold the same standards, the cantilevered machine will be more expensive. You can find much more design information in the must-have book, The Mechanics of Rollers. Baggy webs are one of the most pernicious problems in the web industries. Guess what? Cantilevered machines almost guarantee that you will be struggling with this problem on almost every supply roll that you run. The reason is this: top rollers see both weight and web tension pulling down. On the other hand, the bottom rollers see tension opposing weight. The difference in deflection is such that the top rollers sag more than the bottom rollers. This makes much of the machine act like the front of the web is perpetually baggy. This problem adds to the already great tendency to crookedness due to the general lack of alignability of cantilevered machinery. There may be a way to have the best of both worlds. That is, to cantilever the frame to simply supported rollers. With this arrangement, you can still have nearly the same ease of access, but have the added benefits of alignability and resistance to deflection. Of course, by the time you do this, you may end up with a more expensive machine than simply supported frame. Some unwinds that must bear a heavier weight use a front support that snaps into place when in run and snaps out of the way for roll change. Of course, the web world is more than a little bit wide, and there are plenty of exceptions to every rule. One very practical exception to the previous recommendations are for ribbon-like materials, such as cassette tapes, ribbons, strings, and wires. Here, the in-plane bending resistance of the ultra-narrow webs are hopefully small enough to not cause web damage and wrinkle distortion that is risked by wider webs whose rollers are not precise enough. Thank you so very much for watching this module in my Plant Practical series. Please stay tuned for more roller, web handling, and web converting topics.